Lesson 13-1, the Pythagorean Theorem. And in this lesson, you learn to use the Pythagorean Theorem to solve problems. Why is this important? Because you can use the Pythagorean Theorem to solve problems involving sailing and travel. And let's take a look at this real-world application on sailing. So one of the most prestigious sailboat races in the world is the America's Cup in 1995. For the first time in a 144-year history of the race, one of the sailboats, America 3, had an all-women crew. Theirs was one of three U.S. boats vying for the most prized trophy in sailing. So a sailboat's mast and boom form a right triangle. The sail itself, this is your mast right here, and this is the boom. Okay, so boom and mast create a right triangle. The sail itself, called the mainsail, is a shape of a right triangle. Okay, now recall from in the past that the opposite side of a right triangle is called the hypotenuse. Okay, remember this. The opposite side of the right triangle, right there, is called our hypotenuse. The side is always the longest side of the right triangle. The other two sides are called legs of the right triangle. So these are the legs of your right triangle. So to find the length of any side of any right triangle, when the lengths of the other two are known, you can use the formula named for a Greek mathematician named Pythagoras. Okay, and the Pythagorean theorem is simply this. If A and B are the measures of the legs of a right triangle, and C is the measure of the hypotenuse, then C squared equals A squared plus B squared. So if this is your C, and this is your A, and that is your B, okay, this will hold true that C squared is equal to A squared plus B squared. Now, where did this formula come from? Okay, let's find out. I got a video on this, and let's watch how this formula came about. Okay, and watch, and it's very interesting. All right, so that was a good video on the why you can see that how a squared is a squared plus b squared is actually c squared. So you get the square of a plus the square of b, and that is actually c squared. Okay, so you can use the Pythagorean theorem to find the length of the hypotenuse of a right triangle. Remember, this only works for a right triangle, no other triangles. Okay, when the lengths of the legs are known. So find the hypotenuse, okay, of a right triangle if a is equal to 12 and b is equal to 5. So this is your c, and that's your b, and that's your a. And traditionally, we would designate the shorter leg as b, and the longer leg as a, and the longest side as c. So in this case right here, okay, we can interchange it, where the shorter leg would be b. So I would make this my b. Let me erase that so you won't get confused. We'll make it the same. So my leg would be b, and my longest leg would be a. Okay, so this would be a, but it's actually the same thing. You can designate it as a and b, but traditionally the shorter leg is b and the longer leg is a. The longer side would be c. Okay, so let's go back to this problem, and let's answer this. Find the length of the hypotenuse of a right triangle if a is equal to 12 and b is equal to 5. So first write down the formula c squared is equal to a squared plus b squared, and then substitute the values for a and b. Then square 12 and 5, which is 144 and 25. Add them together, that will be 169. And then to be able to solve for c, okay, we need to undo c squared, the square of c, which is getting the square root. So once we get the square root of c, we end up with plus or minus radical 69. Okay, remember there are two values of c which will give you 169, and that's why it's plus or minus. Okay, that will be negative 13 and 13. But the problem is we are disregarding negative 13 simply because there is no such thing as a negative length. Okay, so we only accept positive 13, so the hypotenuse is 13 units long. Okay, let's take a look at example number 2. Example number 2, find the length of side A if we know that b is 9 and c is equal to 21. Round to the nearest hundredths place. Okay, so first we get to write down the formula. C squared is equal to a squared plus b squared. Substitute the values that we know. We know c and we know b. So this becomes 21 squared equals a squared plus 9 squared. And then we simplify. This is 441 and 9 squared is 81. We solve for a squared by subtracting both sides by 81. You get 360. And then we simply get the square root of a squared, get plus or minus radical 360, or approximately 18.97. Remember, we disregarded the value negative 18.97 because there is no such thing as a negative length. So only the positive value has a meaning in this particular solution. Okay, so we use a calculator to find 18.97, so it becomes easier. So the length of the leg to the nearest hundredth is 18.97 units. Okay, so the following from there. Oops. Okay, I guess we need to go to the next slide. The following corollary based on the Pythagorean theorem can be used to determine whether a triangle is a right triangle. So corollary to the Pythagorean theorem is this. If c is the measure of the longest side of the triangle, and c squared is not equal to a squared plus b squared, then the triangle is not a right triangle. So, if c squared is not equal to the sum of a squared plus b squared, then it is not a right triangle. Okay, and we know for a fact that c is the hypotenuse is always our longest side. So we can look at example 3. Determine whether the following side measures would form right triangles. 6, 8, and 10. We know that the longest side is always your hypotenuse. So 10 would be our c. Since the measure of the longest side is 10, c is equal to 10. And we know that our shortest side is always our b, and the longer of the two legs will be our a. So we have a is equal to 6 and b is equal to 8. determine whether c squared is equal to a squared plus b squared. Okay, then we substitute the values. 10 squared is equal to 6. Is it equal to 6 squared plus 8 squared? That'll be 100. Is it equal to 36 plus 64? The answer is yes. So in this case, the triangle is a right triangle. If you look at letter B, again our longest side is 12. Okay, that is our C. Our A is 7, and the longer B would be 9. The longer of the two legs. Okay, if you notice in this case, the longer leg, the shorter leg is 6, and B is equal to 8. Okay, in this case, A is equal to 7, and B is equal to 9. So we want to find whether C squared is equal to A squared plus B squared. Okay. We want to find out. So since from there, we now have 12 squared. Is it equal to 7 squared plus 9 squared? We have 144. Is it equal to 49 plus 81? The answer would be no, because 144 is not equal to 130. Therefore, in this case, c squared is not equal to a squared plus b squared, so it is not a right triangle. Okay, and let's take a look at the last example. Okay, before we do that, the secret word for this particular lesson would be wizards. The secret word would be wizards. So in example number 4, Aztec farmers kept records of their farms, including the dimensions and area, by using measuring ropes that measured length with a unit called a quahutil. I think that's how you pronounce it. Okay, about 2.5 meters. They were able to make accurate calculations. Because of the rough terrain, very few farms were rectangular. So in the farm shown at the right, the farmer measured 3 sides of the farm. He had trouble measuring the fourth side because it was located in a dense forest. So find the measure of the fourth side. So this is our land right here, okay? And this is the one located in a dense forest. So we have this side is 26, we have this side is 32, and we have this side is 10. So we create a rectangle right here. And if we create a rectangle, the other side would form a right triangle. And we know that the length that we want to find is C, okay, and that's our hypotenuse, okay. We know that B is equal to 26, and we know that A is equal to 32 minus 10, or simply 22. So let's solve this. Let's see, represent the length of the fourth side of the farm. Note that this is the hypotenuse of our right triangle, as we mentioned. So use the Pythagorean theorem to find C. So let A equal to 32 minus 10, or 22. We just mentioned that. And B is equal to 26. Then we simply solve the resulting equation as C squared equals 22 squared plus 26 squared. Simplify that, we have C squared is equal to 484 plus 667. Simplify that further. C squared is equal to 1160. And using a calculator, C is approximately equal to 34.06. So the length of the fourth side of the farm is approximately 34.006 quahitals, I think. Okay, so check the solution by substituting 34.06 for C in the Pythagorean theorem. And now we have, okay, here C squared is equal to A squared plus B squared, and let's substitute 34.06. Is it equal to 34.06 squared is equal to 22 squared plus 26 squared? We know that it is. So we checked our solution, and that is our answer. And that's our lesson. Thanks for watching.